All right, so we asked that you had the first page of the yellow packet done for today, and then today we're going to continue on with that, the law of sines. Law of cosines is the next page in the packet. We are not in the yellow packets at all today. Okay, we're on your own for notes, so get out something to take notes on. Okay? So we asked that you remembered what the law of sines was from your geometry class, and the law of sines is written here on this slide. It is the sine of angle A is divided by side A is equal to the sine of angle B divided by side B is equal to the sine of angle C divided by sine C. Now we use the law of sines to solve triangles. Okay? And the reason that we need the law of sines is we have right triangle trig. We have SOHCAHTOA and we have the Pythagorean theorem, but those only work on right triangles. And unfortunately in this world, there are more triangles than just right triangles. So we needed something else. So we developed the law, or I shouldn't say we, because I had nothing to do with it. The people much smarter than me developed the law of sines from the area formula of a triangle. And you should have done some of that in the last couple of days. Okay? So the nice thing is this allows us to solve any triangle for all three angles and all three sides. Okay? So I ask you, and we can do this together if you will, okay? I ask you to solve this triangle. Okay? So by solving this triangle, what we are asking you to find is the measure of angle A, the measure of angle B, the measure of angle C, side A, which is opposite angle A, side B, which is opposite angle B, and side C, which is opposite angle C. Okay. Knowing the things that you know from geometry, the three angles of a triangle add up to be 180 degrees. So angle A is going to be 180 degrees minus 45 degrees minus 70 degrees, which makes angle A be 65 degrees. So angle A is 65 degrees. Angle B we already knew was 70 degrees. Angle C we already knew was 45 degrees. Side B we know already as 15. Okay? So now it's not a right triangle because none of my angles are 90 degrees. So now what I can do is I can set up the law of sines. The sine of angle A, which is 65 degrees, divided by side A, don't know it, is equal to the sine of 70 degrees, which is angle B, divided by 15, which is equal to the sine of angle C, which is 45 degrees, divided by side C. The law of sines only works if we have an angle and its opposite side. Otherwise, we can't use the law of sines. That's the limitation to the law of sines, which then is when the law of cosines comes into play. Yeah? So I take that green equation and I break it up first into those two, and I would cross multiply. So I would get A times the sine of 70 degrees equals 15 times the sine of 65 degrees, which then would give me A is 15 times the sine of 65 degrees divided by the sine of 70 degrees. I would also get, using those two, that C times the sine of 70 degrees is equal to 15 times the sine of 45 degrees. So that C then is 15 sines of 45 degrees divided by the sine of 70 degrees. And now here's where I go to my calculator and I figure out those two values. So if I go, should be up, there it is. If I go, I got one of those, and I got 15 times the sine of 65 degrees divided by the sine of 70 degrees. Remember, you can always override, like currently my calculator is in radians. I can override that by using the degree key. Gives me 14.4671. And then did it again. Why do you do that to me? I literally just want to change that. Whoa, whoa, whoa. What is going on? And I get that one. 11.2873 for my other one. Now, most of the time, we will round to the tenths in our final answers. Okay? So I would say that side A here is 14.5 units, and side C is 11 units. Does anybody remember from back in geometry how to check if we're right or not, or one of the logic checks that we could run right now? Yes, what?
Divide sine 65 divided by 14.5. Memorize what that is.
Or just write it down quick, jot it down. Yep. Okay. We could run law of sines on all three of them, and all three of them would get us the same thing, hopefully. Okay. That's one way to check it. Another way to check it is, okay, biggest angle goes with biggest side. Okay. Biggest angle goes with longest side. Okay. So when we're looking at it, angle B is the biggest angle, so side B had better be the longest side. Angle C is the smallest angle, so side C needs to be the shortest side. Okay? And it works out. So those are the 6 answers that we need to generate when we say solve the triangle. Okay? When it's a solve the triangle, you need to generate 6 answers. Okay? We'll give you 3 of them. All right? So let's talk some logic behind the law of sines. Okay? So, In a non-right triangle, because if we had a right triangle, we would just use SOHCAHTOA. In a non-right triangle, and we have given the three sides, side, side, side. That becomes, because I don't have an angle to complete one whole fraction in the law of sines, this becomes a law of cosines problem. And we'll get to that next week. Okay? The nice thing about the side, side, side case is that there is only one triangle possible. Okay? It will only produce one triangle. Okay? We just have to use the law of cosines then to solve for it. In a side angle side case, our triangle would look like that. The nice thing is there's only one triangle that's possible. The downfall is it also is a law of cosines case. Because again, we don't have that complete fraction in the law of sines. In the angle side angle case, we just did an example of one like this, where only one triangle was produced. And the nice thing is because we have both angles, we can easily find the third angle by subtracting those two from 180 degrees. So we are allowed here to use the law of sines. Very similar to angle, side case, where if we connect these and make that look nice and pretty, we get one triangle again, and we are allowed to use the law of sines. In the triple angle case, we can't solve that triangle because these two triangles have the exact same angles. And I could come up with a third one that has the exact same three angles. And a fourth one, and a fifth one, and an infinite one. Okay? Because they are similar, we can't solve it. Okay? We have to have a second triangle with a side in it in order to solve the one triangle. a side, side, side case, one triangle is possible. We need to use law of cosines. Side angle side, one triangle is possible. Law of cosines. Angle side angle or angle angle side, one triangle is possible, and we can use law of sines. Okay, we just did an example of that. Triple angle, 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 angle case, can't solve. Okay, got to have a side length, at least one side. Okay. Now, that leaves one last kind of problem that we can give you. Okay? And that is the angle side side case. Okay? So if you're solving a triangle with your angle side side, okay, you would have an angle here, a side there, and a side there. And so my question is does this make, is this true? Actually, we shouldn't even put it in purple. Is this truly a triangle? Okay? So I'm going to have you actually try one, because you can use the law of sines on this one, because we have one complete angle and side pair. So what I would like you to do now is I would like you, given this scenario, I would like you to find me just angle B, please. Okay. So find me angle B right now. What did we get? Or I should say, what did you get for angle B? 64.7832-ish? Uh-oh. That's not what'd you get?
52.96.
Okay, I don't like that one at all. Okay? So I'm thinking, so angle B here, we said what was 64.7832-ish degrees? Okay? Here's the problem. I got Let's see who's right. Let's run law of sines. Okay? So we have the sine of angle A, which is 20.5 all over 12, equals the sine of angle B, over 31. Okay? So if this is truly right, or if you're right, let's check and see who's right. Okay? So let's go. So, oops, I gotta put my pen down. Clear ink. Okay? So let me get a new page going on here. Okay? Add calculator. Okay? So I want to know what the sine of 20.5 degrees divided by, what did we say, 12? By 12 is. Yes? Okay? And then I want to compare that to the sine of, what did we say, 64.7832 degrees. And that gets divided by 31. So you guys are right. Let's just check me. Because I've been known to make mistakes before. I know. What did I say? 115.217 degrees? Uh-oh. Who would have thunked it? Who would have thunked it that I did it right too? It's called the ambiguous case of the law of sines. Okay? So, let's investigate this
How did you get that?
How did I get what?
That 115.
Oh, I did some good stuff.
Whoa.
Some really good math.
Okay.
Okay? I took your answer and I subtracted it from 180 degrees.
Oh, so you got C.
No, I got B.
Okay.
Yeah. Right? So, let's first talk about what ambiguous means. Okay? So, does anybody have a definition of the word ambiguous? Anybody got a definition of the word ambiguous? What you got, Paul?
Oh, Mark was just saying something.
What you got, Paul?
Paul was just saying that's when you can live on water and land.
That's amphibious.
No, that's what Mark told me.
Okay.
See how it played
Alright.
off?
Okay. All right. So ambiguous means that you are open to multiple interpretations. Yes, I need to know how to spell interpretations. Okay. All right. So, the ambiguous case only happens when you are dealing with your angle side. Okay? All the other cases, one triangle is produced. It's just in that angle side case that you've got issues. Okay? So, if your given angle is obtuse, so here is my angle, here is one side, here is my other side. Okay? So in that case, if A is greater than B, we produce one triangle. So if my opposite side is greater than my adjacent side, we produce one triangle. You will want to write this down because there are 6 different scenarios. Okay? If the given angle is obtuse, but my opposite side is smaller than my adjacent side, we don't get a triangle. Okay. So, first have to look at your given angle. If it's obtuse, and your opposite side is bigger, we get a triangle, use law of sines like normal. If we have the opposite side smaller, as the small side given, no triangle is produced. Okay? Now, if we're given an acute angle, because remember, if we're given a right angle, it doesn't matter. Okay? Because we're just going to use right triangle trig. Okay? So if we're given an acute angle, here's my angle, side B, side A, where A here now is bigger than B, we only get one triangle. Okay. Here's where things get crazy. So, let's label our picture. Here's our angle. Here's side B, our adjacent side. Here's side A, our opposite side. And in here, this is the height of the triangle. We'll call it H. Okay? If A is equal to H, so if A is equal to H, what basically happens here then is this side comes to here, and what do I have? I have a right triangle, and I use right triangle trig. If A is less than H, okay, so A is shorter than H. Look what happens here. So now if I take this, oops, there, I want to take this, and I swing this through, do I ever get a triangle if A is less than H? Never get a triangle. So that's a no triangle case. Where it gets cray-cray is here with when A is bigger than H. So if A is bigger than H, I get a triangle there, and I get a triangle there. Okay? So I get two distinct triangles. Okay? And that's where we'll pick up tomorrow. Okay? I understand that right now it's as clear as mud, because we haven't gotten to an example yet. Okay? But we had to get through all of this so that tomorrow we can produce an example, and then, whoa! It'll all be clear.